Hello, everybody. We will start very soon. Just waiting for last people to join us. Thank you.
Hello, welcome everybody. Thanks for being here, for watching us, especially today. That's Saturday. We surprisingly we had like 400 registrations for this webinar. Although we know that many of you can't do it because of time zone or the weekend. So don't worry. We're gonna you can replay the webinar. You can watch it again as many times you need in using the same YouTube link, but also it will be available in the same platform, the educational platform that you registered for this webinar. So my name is Sergio Alonso. I'm responsible for training at Contromat, architect and associate professor at Polytechnic University of Valencia. So together with my partner Diego, that he's going to be in charge of this webinar and the course related, we created Contromat many years ago in 2011 as a Authorities Rhino Training Center and a Rhino Fab Studio. So we offer, as you can see here in the website, if you want to take a look to our main website, we offer here three main activities linked projects. That means that here you can take a look to our designs, basically with interiors. I'm gonna change here the language to English. So interior design, furniture, pro design. So you can take a look to that. Always, working with Rhino Grasshopper. Um, there are another activities with are focused more with digital fabrication. So here you can you can find activities of 3D printing, prototyping, laser cutting, engraving, and so on. And our main activity it's training. Okay, so here you can find many workshops with different lengths. Some of them short ones, like the workshop we are giving in 2 weekends, the Grasshopper G code for 3D printing, but all others with a longer duration, like our, let's say, most important or more intensive workshop is the Master in Parametric Design, which currently we have the autumn edition. We finished in February, and well, I can tell you in a few days we're gonna open a new edition, which is gonna be in spring at the end of March. So stay tuned because we have early bird spots there, and I can tell you also, well, some workshops there are no dates available because we are really busy, to be honest. But in let's say in a few months we're gonna create a new workshop that is about robots and Grasshopper, of course. And if we have a little bit of time, we're not sure about it yet, but here you see that there is something like 1 month workshop, like in the summer, in July. So we will try to give you these similar contents in February, but it's not sure. Anyway, if you have some doubts for training activities or something else, you can contact us here in the contact. So here you can send us an email or a WhatsApp, whatever you need. The platform you have used for the registration, I guess, is our online platform. So here you can find the other courses are usually hybrid. So some parts are on site, some parts online, or otherwise could be just live online courses. But in this case here, you can find in Spanish and English, you can find pre-recorded workshops. So with different, so here you can find the webinars, but also you can find intro to Grasshopper, intro to Rhino. So small, let's say, very very short courses that you can do it this and at your own pace with your own rhythm. So wherever especially if you are working or busy and you cannot stay on site, there's also another option to learn new tools and activities. So I'm gonna come back here to the main website. Okay, so I think it's time to just introduce my partner Diego, that he's gonna be in charge of the webinar and the related course. He's also a co-founder of Control Math, and a professor at European University of Madrid in architecture, and he wrote a book that you can find on Amazon, also with a clear connection of advanced Grasshopper techniques for 3D printing. So, I mean, we are really lucky that he can do it today. A nice webinar, I hope, and well, enjoy and see you soon. Bye bye.
Thank you, Sergio. Thank you very much for the introduction to the course. Um, First of all, I would like to start with a presentation about what the course is about and the importance of learning G-code. And then we will go into Rhino and Grasshopper. So if our users are connected via the laptop or the computer, maybe they can open Rhino and Grasshopper in the meanwhile. And we will try to do something very simple to just try to understand what is the base of creating a G code in Grasshopper. But first of all, let's understand why it's important to learn G code. So I'm going to share my screen. There we go. Okay. So this course is based basically on the book that I wrote with Gianluca Pugliese from WASP, like just in the pandemics. The book is called Advanced 3D Printing with Grasshopper for Clay and FDM, but I always say that it should be renamed as the most basic 3D printing with Grasshopper, because this book goes into the base of understanding G code. No? In the end, we can do advanced stuff or any kind of stuff, but the thing is that the book goes into the base of understanding how to move a CNC machine, basically a 3D printer. Um, there are some examples from the book that we will explain during the course. I know that some users or some viewers of the webinar maybe have bought already the book. Some of them have read it and they give me feedback in Instagram. That's amazing. I love it because we can share problems or things that are not working for them or anything. So feel free to contact me at any time. But the thing is that there are many examples that or that maybe are not that deeply explained, or that the reader of the book had no time to go into them. So with this course, I will try to find the base of everything and try to go through those examples like these ones of the pictures in order to understand how to control the G code to create this kind of geometries. In the end, we could do anything. These are just some examples. No? For example, I love working with clay, and in that case, controlling the G code is extremely important, because when you're printing clay, the seam, it's always a problem, basically because the seam will be displayed on the edge of the model. And when you're doing clay, you don't want to have a seam or something like that. Also, you cannot modify that easily. So for clay, it's very important controlling the samples. We have collaborated with many designers. This one, for example, is an example from an artist, Julie Conrad, from Luxembourg. This is a complex object that it was not easy to achieve, and so we had to print first the exterior part, then the interior part, then connect them in between, and without controlling the G code would be completely impossible, basically. Or collaborations with other artists, like for example Antonio Marest, here from Spain. Are some pieces he did, some vases, large scale, 1 meter height almost, where we were changing the colors because the printer had a pellet extruder. And so controlling these patterns, these waves, etc., is not that easy without entering into the G code, because most of the time we're not working with an STL file. This is something I will explain later with Grasshopper, okay? But we're basically doing the path for the printer. And that is extremely important, for example, for large scale models. This was printed with WASP 3MT, the big printer of WASP, of 1 meter diameter by 1 meter height. This is part of an exhibition here in Spain for 3D printing, Reimprimir la Realitat. And we were with low poly in charge of doing these walls in like this type of Voronoi design and so on. So it was really important to control the path with single lines. Double lines were needed. Try to minimize the troubles in order to save time, to save material, and these kind of things. And that comes especially important when we're talking about robotics with 3D printing in this case. So when robotics, you have to control every single point of the path of the robot with many restrictions, like the robotic volume, work volume, or the speeds and so on. But as you can see in these diagrams on the left, that represents the path, and depending on the diameter of the nozzle and so on, the control of every single angle of the polyline, it's very important to achieve a good result. This is something that our friends from Nagami do amazingly. No? So they have many works. I invite you to visit Nagami. Indeed, one of the founders of Nagami was our former student from the master that Sergio was explaining. And I love this example they did, that is kind of wireframe printing. You see the robot, how it is moving the extruder. And basically for this type of works, you need to control every single point of of your model. It is not something that you can give to any slicer like Cura or like Prusa slicer or anything like that. No? Or once you know how to control the G code, you can use it for printing, for a robot, for a 3D printer, for a milling machine, as you can see here that it is doing a parallel finishing. You can use it for any kind of purpose related with CNC, numerical control by computer. No? So this is an example that I love to do. I love to work with robots, pen plotters that basically are 3D printers, like in the video. That is a Ender 3 V2 version that you just adjust the extruder to add like a pencil or a brush or anything, and in the end what you do is to control the motion of the printer, and the output in this case is like a painting. No? So I find the G-code control extremely important for this type of works and many others. During the course, we're going to work at a small scale, and all the examples that I developed for the course are done with an Ender 3. Ender 3 from Creality is one of the most popular printers, very cheap. You can buy them secondhand for $100. It's extremely simple. And so that's why I use this machine, to show that it is not something that you need a robot arm or something like that. No? So we will start with the basics, with what we're going to do today, to understand how it works, basically. And then we will move forward into more complex things. So one of the first things we're going to do is the spiralized. So how to create a continuous curve out of our model, as you can see in this example. And we will learn to calculate the value for the extrusion. Calculating the E value is not that easy, especially if you want to change the nozzle size or you want to change the layer height and so on. So we will learn how to put all those parameters into relationship in order to have like achieve a good result. Then we will go to the bottom and find the best strategy to do our basis, the base for the designs. In this case, this video is not running, but it's basically doing the there we go. It's basically doing the base design that can be done as contours or can be also spiralized or many other things. No? Once we know how to do the walls and we know how to do the bases, it's just putting together those strategies, and after the base comes the walls. As we have total freedom to print almost anything, we can start exploring non-planar possibilities, non-planar designs, and at the same time we'll have to control the variable extrusion of the extruder. It means that, like for example in this example, that the layers are compressed and expanded on the sides, we'll have to extrude less material in the middle and more material in the outer parts, in the right and the left parts, no? To have the same thickness for the material. At the same time, we will try to simulate what's going to happen in the 3D, so it's not just curves. We will see them like physically, and we will control the preview of the model with different colors and so on. So this is typical example for variable extrusion. Obviously, we will have a robot arm to do the course. That is something that we are preparing for the future. No, a course on robotic 3D printing. The robot rotates the extruder according to the normals of the curve or the surface. With the printer, we cannot do that, so we are limited on the heights of the model that we're doing and so on. But still, we can do many things just with a normal 3D printer. As it is very popular, we will also work with waves. So as in the picture on the left, we will learn to do wavy patterns, basic ones, more complex ones, and then we will apply those waves to different surfaces, but connected to black and white pictures. This is a very powerful strategy because the black and the white of a simple picture that you can extract from internet, you can do yourself, you can Photoshop it, whatever, will give you different patterns once you have the weaving system. So the waves are just the algorithm, and then that picture modifies that algorithm according to the blacks and whites. These are some examples. So it can be applied to just a planar surface, or once we understand it, we could apply it to rounded surface and more complex stuff. This is an example that I did to illustrate the possibilities of printing G-code with this type of printer. So I was trying to use the maximum volume of the printer. As you can see, this is part of a project of a lamp, but we're gonna do it also during the course at a smaller scale due to time reasons. And the same as our friends from Nagami, we will explore the possibilities of wireframe 3D printing. Basically, it's everything the same. What it changes from here to the previous one is that in the previous one we were using an algorithm to create waves, and in this other we're using an algorithm to create like some kind of triangular pattern in the air. So basically, we have to do a 3D model. That 3D model, transform it into a wavy pattern that goes up and down, with that kind of triangles, and then the printer will follow those coordinates. So the printers that you have at home can do anything. It's the same as mine. Every 3D printer in the world can do this. The problem is that sometimes we are limited by the slicers, by the software. The software, the slicers are amazing for standard 3D printing. They have all the parameters that you need there. But when you want to get out of the box, let's say, then you're very limited by that software. But in Grasshopper, any kind of line that you're able to design can be 3D printed, basically. And then we will move into something more complex that looks more simple in the end because it's just a couple of cones, the typical example. But this means that we have to 3D print two objects. And so we have to calculate the troubles, understand the troubles. The trouble is the motion of the printer without extrusion. So we have to move from one cone to the other cone. We'll have to control two speeds, one speed for printing, the speed for the trouble that is going to be different. So the algorithm in Grasshopper is going to become more complex every time, as well as we will have to learn to randomize the seam. No, we'll see. I will show you some examples during the course where if we don't randomize the seam, the finishing will not be good enough. Okay, so there are many details in here that we have to control, as for example, the retraction of the plastic back again into the tip of the nozzle. That is not that easy as it could look like. So in the end, we will be working like a normal slicer. No, I made a test of my system with Grasshopper and the system, for example, in Cura, and the results were the same, even better in Grasshopper because you have more freedom and you can control them better. No? If you want to know more about what we're doing, it's better that you can follow us in Instagram, ControlMath. There we will publish all the courses that we have. And in my personal profile, you can see maybe the weird things that I'm doing here with some students or by myself. Okay, so we invite you to follow ControlMath, especially in our social media like LinkedIn, Instagram, and some others. So now if you're ready, I would like to open Rhino and Grasshopper and start doing something interesting. There we go. We will start with the beginning of the course because it makes no sense that we try to do something super advanced if we don't know how to do the basics, basically. So I have a presentation here. I love to use Grasshopper for everything. If you research a little bit on me, you will find a video that says how to win lottery with Grasshopper, no? Because I also try to win the lottery with Grasshopper, because Grasshopper is just a data management software that can work with geometry, but also it can work with data. So the same as we work with data for a G code, that is basically coordinates, we can work with data from a web page or from a database from the lottery or anything else. No? So I like to do also the presentations in Grasshopper with my drawings and the explanations and so on. So first of all, we need to understand, probably you are experts on 3D printing, or maybe experts in Rhino and Grasshopper and 3D modeling, or maybe you have no idea about this world. So I'm gonna do like a very fast introduction about 3D printing to see where we're going to put our focus. And basically in 3D printing, there are two types of technologies, the one of extrusion, FDM, and the one of sintering or binding. In the one of extrusion, we add the material on the build plate. And that build plate could be preheated or not, and the material could be plastic or could be many things. And in the sintering system for 3D printing, like SLS, SLN, SLA, or DLS, that are the most common ones, the material is the same as the build plate, and there is another agent that hardens or sinters part of this material. For example, it could be powder like plaster, and the sintering material is water, or it could be metal for metal 3D printers, and then the sintering is a laser, or the ones of resin that probably you know that they use like laser UV light or screen like a LED screen. No? But we're gonna focus on these other ones, in the ones of extrusion, because are kind of more simple, and so the G code here is easier to control. FDM is the general name for this type of machines, fused deposition modeling. If it is a specific for plastic, it is called FFF, fused filament fabrication. And these are the most common materials: ABS, PLA, nylon, PTG, and they could be, the material could come as filament or pellet. Pellet are small balls that melt directly into the extruder. Okay? But it is not only plastic what we could use for these machines. That's why I was showing you those examples. We could 3D print clay. In that case, we don't need any kind of temperature to preheat the plastic. It could be concrete, it could be chocolate, or it could be pizza. Sorry for the Italian people that is watching us, but there is a 3D printer of pizza there in YouTube, and you can see how it has three extruders, one for the base, another one for the mozzarella, and another one for the tomato sauce. So yeah, we can extrude basically almost everything. Then we have the printer that could be two systems, delta and Cartesian. If it is delta, it works with angles, and if it is Cartesian, it works with linear motion in 3 axes, x, y, and z. But it does not care. I mean, these are two examples from WASP and from Creality. But we don't need to care about if we have this type of printer or this other type of printer, because there is something in the printer, a software called firmware, that is installed in the electronics of the printer. In the electronics means in this part in the WASP or in this part in our Ender, that will handle the G code that we're gonna give to them. Okay, like this firmware has different flavors. It's called like that, like different types. Could be Marlin, Repetier, Prusa, etc. Depending on how many extruders we have to move, what is the speed or the brand, etc., etc. So it's not important the type of printer that we have for controlling the G code. It's more important the model that we're going to do. For example, if you're a Grasshopper user and you 3D print directly in Grasshopper and Rhino, probably you're modeling in Grasshopper, then you bake that model in Rhino, and it could happen that it is a B-rep or a mesh. B-rep is surfaces or polysurfaces, solids. No? So if it is a B-rep, you have to go via a mesh to create finally an STL file. And if it is a mesh, then when you create the STL file, the mesh is the mesh. There is nothing to change there. And once you have an STL file, you go into the slicer. That could be slicer, simplify, prusa, cura, repetier, or any other. Okay. And that slicer is amazing. It's incredible how people have developed these slicers so good. And there, basically, you control the layer height, the infill percentage of the interior, the build plate contact type, if you want supports or not, with type of supports. In the Prusa slicer, you can print the areas with support. So it's amazing. It's amazing. And this slicer creates something called G-code. That is the file that you have to send to the machine, sometimes with an SD card or with a USB or via Wi-Fi or via Bluetooth or a wire, a connection. And that G-code has three parts. The start protocol that tells the machine to get ready, the core with instructions of our model that is going to be different for every model, and the end protocol that tells the machine that we have finished and it has to turn off or do P or anything like that. Okay. The core with instructions has mainly this structure. This is the text that you could find more or less in the middle of that file of text. G1 is like a shortcut to tell the firmware, this firmware here, that the machine, any of these machines, have to move. Okay, so G1 is part of this G code that is the order to move, basically. Then F tells the machine what is the feed rate, the speed in millimeter minute. And then with coordinates S, Y, and Z, Z is optional, well, all of them are optional, at least we need one of them, we tell the machine what is the next position, the next point, where to move to, basically. And then there is one more thing that if we want to extrude material, basically that's what we want for a 3D printer, but for example, if we're talking about milling machines, this is not necessary, or if we're using a pen plotter, this is not necessary, the E-value. The E-value is the one that moves the stepper motor that pushes the filament or the pellet to 3D print. So if we combine all this information, the machine will tell us or will output something that we have designed. Okay. So this is just for one coordinate. If we have a lot of coordinates, this code will have plenty of lines. Okay. Now, in Grasshopper is the same. In the end, we will finish with a similar G code, but we don't need a slicer. This is the key, that we don't need to get out of Grasshopper. We will do all the process, all the steps in Grasshopper. So if your model is in Grasshopper, it could happen that it is a VREP, like a solid or a mesh, or curves, or polylines, or just points. We could 3D print points, or we could 3D print a text file made out of X, Y, and Z coordinates. Because we're going to use one of my favorite tools in Grasshopper, that is concatenate, that is able to create a text similar to the one that we need for the G1 order to move the 3D printer. So, for example, if we have a VREP or a mesh, like this one we have in here, this was our STL file, no? We have to transform it, we have to act like the slicer, so we have to transform it into slices, into sections that will be, if it is a VREP, maybe they are curves. If it is a mesh, it will be for sure polylines, like these ones that we have in here. So for that, we will use a tool that is Contour. Maybe you're familiar with that tool if you have used Rhino before to make sections and so on. So this is basically the output of Contour tool. And from these polylines, we will extract the vertices, the points, and from those points, the X, Y, Z coordinates. And once we have split the X, Y, and Z coordinates, it's just a matter of concatenating that information with a text that says move at a certain speed or feed rate and a certain extrusion from point to point. So basically, this information is the information that goes into concatenate and outputs a G-code. This is beautiful because we don't need to get out of Grasshopper, and we have total freedom. So if my polyline is not like this, my polyline is doing something like this in 3D, no, this is the path, then I need just the point here, the point here, the point here, the point here. So I'm starting to print like wireframe mode, non-planar, etc., etc. Obviously, we have other problems. Not everything was going to be so easy and beautiful. That we don't have any slicer, any software like the softwares from here, with all these parameters already pre-made for us, only to change them and so on. So the layer height, that is something super basic, will depend on our contours or the drawing that we do or the ISO curves or anything like that. So we'll have to control the layer height. If we want an infill, we have to design it. This is super interesting also because you don't depend on the infill options that the slicers have. So for example, if you're doing a pavilion that has a section like this, maybe you don't need infill in this part, but you start needing infill here, and maybe you need a lot of infill in this part because there are some bending moments or some efforts, and then some infill here, and that's it. So your slicer is not able to do something like this. That's good and that's bad at the same time, because if you want an infill like that, you have to draw it. You have to draw the polyline for that infill, but you have total freedom to create any infill. But there is no parameter infill, no, that you can choose and change the percentage, for example. So more freedom or more work, as you prefer to understand it. If you want any kind of build plate contact, like a RAF or a brim or something like that, also you have to design it. If you need troubles because you have to move from one side to another, you have to design and control those troubles and modify the seams and randomize those seams and everything. If you have to add supports, better not to add supports because you need to design those supports. But the idea is that we're printing things that should not use supports. In clay, it's not good to have supports because when you remove them, maybe you could break the clay itself, the object itself. If you're printing at large scale, it's like prohibited somehow to use supports because you're going to use a lot of material that you have to reuse after. You know how to reuse it. It's more time, it's many kilos of material probably. Maybe you need a grinder to remove those supports because they are huge, so it's complicated. And if you're working with other type of materials like concrete or so on, then forget about supports. So this is more thought on an experimental part or large scale, so supports are not necessary. And temperatures for the plastic or for the build plate, etc., can be copied from another start G-code. Now remember that we have the start protocol. So the start protocol is the one that tells the machine how to prepare, what are the temperatures that we have to use. So this kind of material of parameters, you will have to adjust them in here. It's very easy because you can copy them from an existent Grasshopper 3D file. Okay. Good. So if you're ready, I want you to do this file that is very, very easy, but very clear about what we could do. No? I'm going to start from scratch. There is a bifocals here. That is a small plugin that you can download from Food for Rhino, from our friends of McNeil, that adds the names of the tools. Okay, so if it is the first time that you open Rhino and Grasshopper, let's start from the very beginning. By the way, before I go on, if you have any doubt or any question, you can use the chat of YouTube, but maybe you have to refresh the YouTube right now live because it was not turned on at the beginning. We realized that it was not on, so maybe you have to refresh. I have just refreshed it, the link. I see myself in YouTube now, and now I can see that Sergio has wrote a message that the chat is now available. So maybe first thing that we have to do is to refresh the session of YouTube where you are connected to me right now, and that way you will see the chat because it was not available since the very first minute. So in case that you have any doubt or any question, you can ask us in there. And so first thing that we should do, it's Abby, our friend Abby, thank you. Yeah, it's working. Alex, Ponce Cortez. I see many people here, many friends. Diego Trazzi, nice, very nice. Okay, thank you. So first thing that we should do is the very first time that you use Grasshopper, you have to click in here, launch Grasshopper. If you're already an expert and a big user of Grasshopper, you will have the file as a new file, new document. You will see something like this, no? And everything empty. So we're gonna start with just a simple cylinder. I'm gonna do it myself. I'm gonna use the bifocals, so basically you can see the name of the tool as well as the icon. There's people that prefer to work with icon and people that prefer to work with texts. Okay, so first of all, we're gonna start with a cylinder. You can double click in the canvas or spacebar and start typing cylinder. Maybe you display it without icons, something like this. Maybe you are displaying it with short names, so you will see sil from cylinder. So my advice at least is to go to display and draw full names. Okay, I'm gonna change to icons too because you can see the name of the tool here and the icon too. As I want to use the same example that I have here, let's follow this thing that is a cylinder of 25 millimeter radius by 50 millimeter length. Very easy. Double click, slash slash to open a panel and type 25. Enter. Repeat again. Double click or spacebar, slash slash 50. Nice. Connect this one to radius and this one to length. There we have a very easy and simple surface cylinder-like. So we could 3D print this. This is weird. Maybe if you have experience 3D printing and creating the STL file, like a closed object, a watertight object, no, like polysurfaces or meshes or whatever, because this can be 3D printed. The thing is that we're gonna create the sections for the path of the printer, and for that we're gonna use contour. You can type contour. Careful, there are several types of contours. The contour that we need is the one that says create a set of VREP or mesh contours and connect the cylinder to contour. The point by default 0, 0 is fine. The direction it's 0, 0, 1, so Z direction, and the distance is gonna control the layer height. So let's say that we want to 3D print every 0.5. You just type 0.5, no slashes, because this way you can modify it easily with a slicer. So 0.5, that's gonna be our distance, and there you will see the circles that are the sections of the contours. Let's move forward. Now we have curves. We need points because we have to simplify the information for the G-code as just XYZ coordinates. So what we're going to do is to divide the curve into points. This is very tricky because if I divide it into more points, I will have more resolution and the wall of my cylinder will be smoother. If I divide it in less points, it's like if it would be a low poly design with only a few points. Okay, so this number will give us the resolution of the cylinder, and the previous number, the one of the layer height, the one of the distance, will represent the layer height. Okay, so there we have two parameters that are very important. And then once we have all these points, we will concatenate them with the help of T1 and F for the feed rate. Okay, but that's next step. Let's go to divide curve in our file. Divide curve. Careful, there are several divide options, especially if you have downloaded plugins like me, that I have plenty of plugins. This comes from Paneling Tools, a beautiful plugin for Raya Isa and many others, but the one that we need is this icon, divide curve. By default, it's divided into 10 parts. If I want to display the reality of my printing, we have to use a polyline component. You will see. This polyline connected to points will output what we're going to 3D print, not the previous stuff. Okay, so these green lines represent the 3D printing. That is going to be low poly. It's not an hexagon, it's a decagon made out of 10 parts, 10 sides. No? So it's not a circle. So we want to have more resolution. We have to increase this number of points of the divide curve to something larger. I'm going to type 50 or more, or depends. So you see now how my polyline is more rounded because there are more points, or more simple because I have less points. Okay, so this number will change the resolution of my model. Those points from here obviously are described by X, Y, and Z coordinates. The first column is the X, the second column is the Y, and the third column is the Z. It's 0 at the beginning because we're in the first layer, but then it will change to any Z value, as you can see. Okay? So we have to split this information into those 3 columns and say that this is going to be my X value, this is my Y value, this is my Z, and also I have to add the extrusion amount that we have to calculate, E, and tell the machine to move, and also tell what is going to be the feed rate of the speed. So once we have this information, the machine will move and will extrude, and so will 3D print. To do this operation, we need a very simple tool called deconstruct point. This one here. You see that the icon is like a point split into its coordinates, X, Y, and Z. So the points come here, and what it was a panel with the 3 coordinates, now will be a panel with coordinates only in X, only in Y, or only in Z. That you remember that at the beginning were only zeros. Nice. So basically we have to open the tool. I'm going to leave it here, so if you're following, you can see it. I'm going to open the tool concatenate. Concatenate is a tool that it is in the set text menu. And the magic of concatenate is that you can add fragments of text that the tool will put them together into a final text. We have nothing now, but if I connect the X here, I will have the X values. If I connect the Y values after them, it's not easy to know where X starts and Y starts, no? Or X ends, let's say, rather, and when Y starts. So what you have to do is to open new fragments, new options. So if you zoom in, this is one of those tools in Grasshopper that has the capability to add more inputs. So you have to zoom in and add pluses in between. So I'm going to add a plus for the X and a plus for the Y. So with / to add a panel, X. Now this becomes my X value. / Y. And now this becomes my Y value. This cannot be together. The last number of the X cannot be glued to the Y letter. We have to separate them with a blank space. So We can do it easily if we enter into the panel and just click before the Y and add a space to it. You see how it works. So if you remember the structure of the G code, we'll have to start telling the machine to move. So I'm going to add more inputs here with the information. So / G1, and maybe I can add also the feed rate, the speed, directly in this one. So space, blank space, F, and the speed in millimeter minute. Could be 2000, whatever. And one more blank space to separate from the X. Let's see if it works. I forgot the last blank space. Now, yes, perfect. So this is very interesting. I'm telling a machine to move at this speed to these coordinates in X and Y. But as it is just X and Y, my printing will be flat. I need to grow in the Z, the volume. So back to concatenate. Let's add a couple more of inputs. One for the Z, so / blank space Z. Okay. So we get the Z there and the coordinates for Z value. And finally, we need the fourth motor of the printer to extrude material, because this is going to prepare the machine for motion. It's like move. This is going to set the speed. And this sets the three motors for X, Y, and Z, so they know how to move. For example, if it is Cartesian in X, in Y, and in Z. Okay, but the machine will move. Of course, if we add a pencil, we'll have a drawbot or a pen plotter, no? But if we want to extrude, there is a fourth motor in here that we have to tell that the filament or the clay or anything has to be extruded. And for that, we need to add the letter E for extrusion. So a couple more of this with a letter E. Remember to add the blank space just before E, not like me. Now, much better. And the values for E. The calculation for the values for E is not that simple. It's not something that I have time to explain right now. I need more time. It's something that we explain correctly during the course. Now, let's say that it's going to be any value. As it is a circle and the distance between points is always the same, the E value will be constant, will be the same for this point, that for this point, for this point, because it is an interpolation that the machine does, that the stepper motor of the machine does to add material from this path, from this point to this other point. And so if you tell it to extrude 1 millimeter of material, it will rotate and it will add 1 millimeter of material from one point to the next point. So it's like an interpolation. Now, as this is something not that easy to add, we're just going to say a number, any, 1 from point to point. Maybe it's a lot, maybe it is not enough. I don't know, okay? Because that is in proportion with the layer height and the distance from point to point. And also the nozzle diameter. We have three factors, no? Imagine that we have to control the nozzle diameter plus the distance in vertical, that is the layer height, as well as the distance from point to point. It's not the same value. We have to extrude from here to here. Then we have to extrude from here to here. The amount of material, the volume of material, obviously, it's almost triple in this one. No? So we have to put everything into relationship, the distance with the layer height, with the nozzle diameter, this diameter, to calculate this value here. Okay. But basically, we have it. We have it. There is something weird still that if we move downwards, let me see if I can get it. Yeah, there are some lines, these dark lines that are related with the lists of the model that we have. The model is not done all in one single list, it's done in a data tree, basically because of the contour. What the contour does is that it takes the cylinder and every single section becomes its own list. This is one list, this is one list, this is one list. And so the division points are division points of different lists. It's weird to have the information split by layers. So we usually do a flatten tree. So we deal with all the points together and one more flatten here. So there are no divisions between layers. Okay, that's more related with data management inside Grasshopper that you can find in the menu of set for lists and for data trees. Okay, so I'm using the option flatten tree. If you're a Grasshopper user, you know perfectly what I'm talking about. If you're not, it should be important that you get familiar with this type of contents if you're interested in doing the course. And finally, this describes the model that I have in here. Basically, if I turn off all this stuff, preview off, and display only the polyline, this G-code is explaining this path, this polyline. Okay? But this is not, the machine cannot start printing like this. Like if you wake up and you don't drink a coffee first, no? For me, it does not work. So I need the coffee first. The coffee for the machine is basically the start protocol. The start protocol could be different depending on the type of machine. I have some protocols here for our students when they come to control math for the master course and so on, so they can use them. So depending on the 3D printer that we have the start protocols for all of them. You can get those protocols easily from the developer of the machine. They give you these protocols, or sometimes from a file that was already 3D printed. So for example, if I use Cura, no, as an example, as a slicer, and I 3D print something with Cura, Cura is gonna get this start G code to prepare the machine, and then the G code that corresponds with the model. And then at the end, all these tools and protocols that tell the machine to, for example, to turn off the fan or to set the bed temperature to 0 because maybe the bed temperature was 70 degrees. No? And so all these kind of things can be copied from an existing file that you have already done in Qt Plus or any other slicer. Okay, I have them here ready. I've already isolated them. But for example, if it is for clay, look, it's super simple. For clay, you just need to tell the machine that you're going to use absolute positioning for the coordinates. Always refer to 0, that's what it means. The extruder also could be absolute or relative mode. It means that you can add the coordinates for the values or not. G28, this is super common, means home all axis for the printer. That's when you turn on the printer and it goes to the origin, like beep, beep, beep. That thing means G28. That's the order to do that. And to reset the extruder to G92 to 0 and so on. Okay. So for example, for clay printing, as we don't need to preheat anything, it's extremely simple, and the NG code the same. For plastic, we need to tell the machine to do more things. The industry, for example, not so preheat the bed temperature, so M140, 105, 190, etc. If you want to know more about G-code, I always use the same web page, the RepRap project for G-code. They have RepRap it's a pioneer group of people on 3D printing that decided to have everything open for everyone, for the public to learn, for people to learn. And so if you type in Google RepRap G-code, you will have access to this web page. Let's see if it opens. Yeah. With the explanation of the most common orders in G-code. So G1 is the one that I was explaining to you to move the machine, but there are many. G28, no, the one that I was referring to before, move to origin, to home. And so if you don't know how it works, you just click in here, and first of all, it will tell you if which firmware, this as a support are the firmwares, which firmware supports this tool, all of them obviously, and how it works. You can tell the machine to home in X or in Y or in Z or P or Y for Prusa, specific for Prusa, and they give you an example. Just G28, home all axis. G28 XZ, home only the X and the Z axis. So it's a beautiful web page that if you want to go deeper with G-code to try to understand something by yourselves, I always recommend. And so if we have the start and end G-codes, just copy them, Control Z, and going back to my file to show you as an example, Control V, Command if you are in Mac. And we have to tell Grasshopper that this is the first part, this is the middle part, and this is the end. We can use merge component, where this goes first, this goes in the middle, and this one goes at the end. And so the final output is that we will start with the machine preheating the temperature for the build plate, etc. Then we'll have the coordinates of our cylinder, and at the end we will tell the machine to turn off and to set the temperature to 0 back again, etc, etc. And once we have this, you will say, yes, very nice, but how can I put this into my machine? There are several ways. The easy one, right click, copy data only. Copy data only means copying from here to the right, not the indexes, not the path of the list, etc. No? And then you can open a very, very complex software. Did I open it or not? That is bloc de notas in Spanish. How is this called? Notepad in English, where you paste it and save it as any kind of file, cylinder.gcode. That's it. You just save it, and that file can be copied in the SD card and put into the 3D printer and launch it. This can be done more automatically. This thing you don't need to open Notepad, but I wanted to open Notepad just to show you that it's a text file. It's not something weird. Okay. So sorry if I was a little fast or simple in the explanation or whatever. It was just to give you like an idea of the possibilities of the course and the G-code. So anyway, this is recorded, so we will share the link and everything. Okay. Sergio and me are just checking the chat. If you have any question, I will be happy to answer. If not, anyway, happy to see you here. And there were many people. I don't know how much people are now. 100 people. That's amazing for something little weird as doing G-coding, Grasshopper. So thank you very much for being a Saturday here and joining us. So please let us know if there is any question. Otherwise, we will finish this this nice webinar. Is there a question? Sorry, just tell me. If is it possible to hook it up to other software like textile software through G-code? Textile software. Not sure what a textile software is, but if you're 3D printing textile, if you're trying to 3D print fabrics with 3D printers, like TPU materials, no flexible materials or sustainable materials or this kind of things, any kind of printer could be handled with G-code with Grasshopper. Yeah. There is another question: is that possible to generate 5-axis code from this software? Yes, but it's more complex. Yes. It is possible also to control a 6-axis robot arm, but it is not just like giving X, Y, Z coordinates and the E value for the fourth motor. We have to combine more information. For example, with a robot arm, we have to specify the position for printing, not only with a coordinate, but with a plane. So you have to tell what is the position for the tool to go, as well as the angle. So with a plane, you control the angles for the machine. So with for 5 axes, depending on the machine, we will need a sample file to check what is the information that machine needs, no, exactly, and you could create that information with Grasshopper, the same as we do for a 3D printer or a 6-axis robot arm. Yeah. I think there are no more questions. Hi, brother, can you send us these files? Yes, of course, I could share the file of the webinar. Maybe I can send them. I don't know if we can share it in our webpage. Maybe I will ask Sergio if it is possible, for example, to have in the webinar on the information of the course way to download this file as part of the explanation of the webinar, for sure. Is this course planned for another weekend in the future? Hopefully, yes. I mean, this is gonna happen in the weekend of in 2 weekends, 16th and 17th of December. But the idea is to repeat it also next year. If you're interested on the next edition, send us an email, because for the first registrations there is an early bird discount, so that way we can send an email to the people interested, and if they are sure, they can enroll with a small discount to the course. Would it be possible to use other notes software as Touch Designer? Touch Designer is a software that I've seen people using for design and visualization, no? Kind of processing, like a little bit. We have a student that did our master in parametric design in Grasshopper, and now she uses Touch Designer, and she said that now it's super easy for her to understand Touch Designer because it has the same base than Grasshopper, nodal system, parametric design. So maybe in Touch Designer you can do something similar. And I have not experience with the software, but probably it is possible to create G-code also with Touch Designer. No? Okay, so I think that's all for today. Thank you very much for being there. Really, I'm super happy to see so many friends and so much people interested. And if you have any other further question, please contact us in our contact in the webpage, controlmat.com, or also in our Instagram, controlmat, or anything that could link with us. Final questions. Joseph, is it possible for the points to follow curved vectors instead of straight? Curved vectors, yes. I mean, you can create any kind of vector, but in the end, that vector has to finish in a point. So the information has to be point coordinates. So if you have vectors, in the end, you have to transform that into points. That's how G-code works. The robotic course is coming. Probably it will run during February or March, and the registration will be open next year during January. And the 2 weekends are going to be recorded. They will be available for 24 hours because the idea is to have live training. So in case that you missed something, it will be available during 24 hours. And that's it. Thanks to you all. Thank you very much. And see you in somewhere. Thank you.